All right, so this video is going to be page 2 of this vertical and horizontal tangent line worksheet. So you're going to notice that this page runs pretty similar to the last one. Questions are very, very similar. So this first part here says that we want to show that dy dx is equal to this. And here's the equation that we're given. So we have to figure out how can we get from the equation to the dy dx. So I'm assuming that you've already worked through this and that you have the ability to pause and rewind as you need. So I'm going to fly through this pretty quickly and just explain things as I go. So if we're trying to find dy dx of this guy here, I need to start off by taking the derivative of both sides. So derivative of the left, well, I see a product rule here, and I see another product rule here. So for the first product rule, I'm going to have, so I'm doing the derivative of xy squared. So the derivative of that first piece is a 1, and then I multiply that with y squared. And then I have the first piece, which is x, times the derivative of the second piece, so 2y, y prime. So that's just that first product rule. And then I have a minus sign between them, and then I'm going to have to do product rule again. So I'm going to put a bracket here to remind myself to distribute that negative. The first piece is x squared, so derivative of x squared is 2x. Multiply that with the y. And then we add, and then we do x squared, and derivative of y is y prime. So that's the left side done, and now the derivative of the right side, well, 16 is just a constant, so the derivative of a constant is 0. And so that inside the bracket, that's my second product rule. So let's clean this up a bit. 1 times y squared, well, that's just y squared. We have a 2xy y prime. I'm distributing this negative, so it's negative 2xy, and then a negative x squared y prime. And now we need to collect our terms. We want all the y primes to be on the left. Any term with y prime is on the left. Anything without a y prime is on the right. So this y squared does not have a y prime, so I'm going to subtract y squared from both sides. That means that's going to go away. Negative 2xy does not have a y prime, so I'm going to add 2xy to both sides. That's going to go away. Everything else has a y prime. So we're left with 2xy y prime minus x squared y prime equals, I'm going to reorder the right, so it's going to be 2xy minus y squared. Now we can factor y prime out of both of these on the left. So there's a y prime here, and there's a y prime there. So let's factor that out. 2xy is left on the left, and then negative x squared is left there. And that equals 2xy minus y squared. So now we can just divide both sides by this parentheses. And then it would cancel out with the parentheses on the top. So then y prime is equal to 2xy minus y squared divided by the parentheses was 2xy minus x squared. And then that should be what we were looking for. Yep, that's it. So that's the first part done. Part B says to find all points in the graph of the relation whose x-coordinate is 2. So we're going to be starting from x equals 2. And write an equation for the tangent line at each of these points. So since we're trying to find the equation of the tangent line, I'm just going to go ahead and write out what the equation of a tangent line is. That's point slope, y minus y1 equals m parentheses x minus x1. And that m right there, that is just going to be f prime of x1 comma y1. So that's our goal, is to find f prime. We also need to find the y1, but this is our x1 right here, 2. So I need to take my original equation, xy squared minus x squared y. And that equals 16. Make sure I wrote that right. Xy squared minus x squared y. Yep. So I'm going to take this 2 and I'm going to plug it into the original equation. And the reason why I'm doing that is because I need to figure out, well, where are the coordinates? There could be multiple coordinates where x is equal to 2. So I need to look to see, well, what are all the possible y values that I could get from this? So I'm plugging in x equals 2 into this equation. So it's 2y squared minus 2 squared y equals 16. So 2y squared minus 4y. This is a quadratic equation, and in order to solve a quadratic equation, I have to set it equal to 0, which means I got to move that 16 over to the left. What I see now is that everything is even. All the coefficients are even, which means they're all divisible by 2. So I'm just going to divide everything by 2. And when I do that, I'm left with y squared minus 2y minus 8 equals 0. So then we can factor. What multiplies to negative 8 but adds to negative 2? That would be a negative 4 and a positive 2. That means that I have y is equal to negative 2 and 4 as answers. Or at least we could say possible answers. It could, nope, just kidding, these are answers. So, so the x coordinate for both of these is 2. So I get 2, negative 2. And then also get 2, positive 4. So that's not my final answer. Final answer has to be the tangent line. I'm just putting a box around that because this is where I'm working from for my next steps. So now I need to figure out, well, what is the tangent line for each of these coordinates? So I'm just going to take it one at a time. Let's start off with the 2, negative 2 coordinate. This 2, negative 2, well, this is going to be our x1 and our y1, which could be plugged into this formula here. So all I'm missing is what is f prime of x1, y1. Well, f prime was this, this equation right here. So let's take a screenshot of that. So there's my dy dx. So if I want to find the slope, I can plug in the 2, negative 2 into that dy dx. So the notation for this, you can either write it as dy dx with a bar after it, and then write your coordinate as sort of a subscript at the bottom of this bar. Or if you prefer, you could just write f prime of 2, negative 2. But basically, we're just looking for that slope. And so we're going to be plugging in 2, negative 2 into this equation. So 2 times 2 times negative 2 minus negative 2 squared over 2 times 2 times negative 2 minus 2 squared. 2 times 2 is 4, times negative 2 is negative 8, and then negative 2 squared is positive 4, and that's a minus in front. On the bottom, 2 times 2 is 4, times negative 2 is negative 8, and then minus 2 squared is minus 4, top and the bottom are the same, so that's just going to end up being a 1. So the slope here is 1, so the full equation of this tangent line would be y minus y1. My y1 is negative 2, so that's y plus 2, is equal to the slope, which was 1, parentheses x minus x1, and x1 is 2. So that is my first tangent line. All right. Now let's do it again with this other coordinate, the 2, 4. So I'm just going to write this as f prime of 2, 4. It's easier to write. So we have 2x is 2, y is 4, minus y squared over 2, 2, 4, 2 squared. 8 minus 16 over 8 minus 4. Negative 8 over 4 is negative 2. So then that tangent line would be y minus 4 equals negative 2 parentheses x minus 2. I feel like I've made a mistake. Let's see. So 8 minus 16. Dang it, yeah, I did make a mistake. All right, let's back up. Sorry about that. My math was wrong here. 2 times 2 is 4, 4 times 4 is 16. I'm sure like every single one of y'all caught that, and I didn't. Sorry about that. So 16 minus 4. So on top we have 0. And then that's, it doesn't really matter what's on the bottom, it's 12. So we get a 0. Okay. So then our slope, our tangent line would be y minus 4 equals 0 times x minus 2. And if you wanted to simplify this, this would just simplify to y equals 4. Either way is fine, but remember, I encourage you just to stop after you stop at the first time that you can stop. So technically, what I just boxed in is the equation of the tangent line, so there is no need to simplify it to y equals 4. All right, moving forward. Find the points in the graph of the relation where there is a vertical tangent line. So just to run through the logic here, if we have a vertical tangent line, vert-tan line, well, anytime you have a vertical line, that implies that the slope is undefined or does not exist. And if your slope does not exist, that implies that you're dividing by 0. Okay, so if you have a vertical tangent line, well, the slope of your tangent line is the derivative. And so if you have a vertical tangent line, that means that the slope of that has to have 0 in the denominator. And this is the equation for the slope of the tangent line. If we have a 0 in the denominator, that means the denominator could be set equal to 0. So vertical tangent line, I'm just going to take that denominator, 2xy minus x squared, and I'm going to set that equal to 0. So that is my starting point here. And we're asked just to find the points. I think in class, the one I solved, I actually found the equation of the tangent line. So we could have stopped as soon as we found the points. So here, we're just going to find the points and stop there. So here I have the equation. I want to try to solve for x and for y. Well, I noticed that on the left there's a common factor of x. So I'm going to factor that out. And then we could say, well, x is going to be equal to 0. And then we have 2y minus x equals 0. So that second piece, I'm just going to say 2y equals x. So I've solved that for x. So I've got two possibilities here, and I need to go through and check both these guys. So let's start off, I'm going to cut this up. So let's start off by checking x equals 0. So I want to look to see, well, is there a legitimate point for x equals 0? So I'm going back to the original equation, which I have written here. And I'm plugging in x equals 0. Notice the left side has a 0 in every term, so we get 0 equals 16. That is an untrue statement. So never is 0 actually equal to 16. Anytime you get a statement that's not true, that means that you have no solution. So there is no way that x could equal 0. So we just cross that out. So now we have to check 2y equals x. So I'm going to plug that into that equation. So I have this equation, the 2y equals x. That's solved for x. So I'm going to replace all the x's inside of this original equation with 2y. So that means I'm going to start off with 2y, and then it's y squared minus 2y squared times y equals 16. So then 2y squared would be 2y cubed. And then I'm going to square this parentheses here, which means I'm squaring the 2 and I'm squaring the y. So that's going to be 4y squared with a minus in front. And then times y equals 16. So then 2y cubed minus 4y cubed equals 16. That's going to be a negative 2y cubed equals 16. Y cubed equals negative 8. Y equals negative 2. So it asks us just to find the points here. And I only found, looks like I only found one. I've got the y value, so let's take this and plug it back into the original here. So then x would equal 2y. So our y we know is negative 2. So that means x is equal to negative 4. So then the full point there would be the coordinate negative 4, comma, negative 2. And that is our only final answer for that part. And then part D, find the points where there is a horizontal tangent line. We did find a horizontal tangent line here, and that had the point 2, 4. Could be that there's another one. We don't know yet. So let's work it out. So a horizontal tangent line means that your dy dx is equal to 0. So I'm going to take my dy dx, which is here, and I'm just going to set that equal to 0. Well, since this is equal to 0 and I have this fraction, I can just take this denominator and multiply it on both sides of the equal sign. And then 0 just times that parentheses, well, that's still equal to 0. So I'm left with 2xy minus y squared equals 0. So really the horizontal tangent line really only concerns the numerator of the dy dx. So now we just want to solve this for our variables. So there's a common factor of y. Factor that out. Set these factors equal to 0. Solve the second one for y. We've got a couple of things to test here. Start off with y equals 0. Plug that into the original function, which is here. So we have x times 0 squared minus x squared times 0. You can probably see where this is going. Everything on the left there has a 0. So we get 0 equals 16. Untrue statement. That means no solution. So y equals 0 does not lead us anywhere. The other thing we have to check is 2x equals y. And we're plugging that into the original problem. So we're going to plug in 2x everywhere we see a y. So it's x, 2x squared in place of the y squared, minus x squared, and then we have 2x in place of that y. Square the 2x, that gives us 4x squared, and then combine that with the x that was already there, the x cubed minus 2x cubed equals 16. 4 minus 2 is 2, so 2x cubed equals 16. Divide by 2, x cubed equals 8, and then take the cube root, x equals 2. Plug that back into the original. So then we'll have y is equal to 2x, 2 times 2, y is equal to 4. So put that together, you have 2, 4, and look at that. That is the same coordinate that we had here. And we identified that as being horizontal because we had a 0 slope on it. So we're done with this, but I'm just going to graph this just to kind of get an idea of what did we really just solve. Like, why is this stuff, important at all? So I'm going to go over to Desmos. And we're going to see what we just did. So I'm going to graph this original equation. X y squared minus x squared y equals 16. So that gives us this weird looking thing. So it kind of looks like a rational equation, but notice on the right here, there's a top and a bottom part. So this is definitely not a function. All right. So here, it said find all points in the graph of the relation whose x-coordinate was 2. So if I just type in x equals 2, this is going to create a bar for us, and we can see everywhere where the graph is equal to 2. That happens there at 2, 4. It also happens there at 2, negative 2. Notice those are the 2 points we found, 2, 4 and 2, negative 2. We also found tangent lines for those. So let's type in those tangent lines. So the first tangent line we found was y plus 2 is equal to 1 parentheses x minus 2. And look at that. We just found the tangent line at that point. So that green line just barely touches the red curve. And then I bet you the same thing is going to happen up here. it looks to me like it should be a horizontal tangent there. So let's type in what we have and make sure it actually matches up. So y minus 4 is equal to 0. And I'm not going to have to type anything else, because that whole right side just goes to 0. And look at that. That is actually a tangent line. Oops. So that's those two things. And then a vertical tangent line. So find the points on the graph that have a vertical tangent line. So we could look at this graph. I'm going to turn off the tan lines we already found. And I'm going to turn that x value off. So looking at this graph, well, where do you think this graph might have a vertical tangent line? Well, here it looks like there's a vertical asymptote. So this definitely approaches x equals 0. But a vertical asymptote is not the same as a vertical tangent line. Vertical tangent line would be right here. So when this thing turns on itself, the rightmost that you see here would be where the vertical tangent line would be. So let's verify that's true. So we found that the vertical tangent line, we didn't actually find the equation of it, but we said that that does happen at -4, -2. So I'm just going to create a point. So parentheses, -4, comma, -2. That creates a dot for me, and look at that. That dot is right there, right where we thought it would be. So that's exactly where the vertical tangent line is. And then down here, find the points in the graph with a horizontal tangent line. So we only found one. So the only horizontal tangent line was right here at 2, 4. And that was the second one.